Hi, students. This is Mr. Halpern. We are going to be doing the next two videos on global climate change, and I created this concept map of the major topics that we should be talking about with global climate change. So if we zoom here really quick, the five major topics that we're going to be talking about are what is it, and what is it caused by? How do we study it? And what are the impacts of it? What places are particularly being affected? And what are some of the reactions that we have for fighting this? To start, we're going to talk a little bit about what it is. So global climate change is a change in climate, not a change in weather. Climate is defined as long-term trends in weather, whereas weather is short-term trends in weather, like temperature and precipitation measurements. So you should know the differences between those two. What is it caused by? Global climate change is caused by the greenhouse effect. The greenhouse effect is basically the effect of greenhouse gases around the atmosphere trapping in heat. And that's typically a good thing. If we didn't have greenhouse gases, we'd be a giant ice ball. So we do want to have some heat that's being trapped. Approximately 30% of the incoming radiation is reflected directly back to space. 70% is absorbed by the atmosphere or Earth's surface. And the outgoing heat radiation from the surface can be absorbed by greenhouse gases. That's what they normally do. And they can warm up the Earth. So this is the process that that it sort of is showing what we just talked about, where you have yellow arrows of incoming radiation, and then you have the red arrows of radiation once it hits the Earth, absorbing that heat from the atmosphere and from the Earth's surface. And the more greenhouse gases we have, the more is absorbed by the atmosphere, and the more that the Earth heats up. So the greenhouse effect is caused by the greenhouse gases, right? These are the gases that absorb heat. And if you take a look for a second, let's look at the trend over history. Over the last 800,000 years, we noticed that carbon dioxide and methane are really spiking right now. They're going really high. Carbon dioxide now is above 407 parts per million, and methane is over 1,900 parts per billion. And as you can also see, really important to notice here is that the temperature also is fluctuating with each of these as well. So as the gases go up and down, so does the temperature. So there's this correlation between the two. The first major greenhouse gas that we need to talk about is carbon dioxide. It is the most prevalent greenhouse gas in the atmosphere, and that's why we talk about it the most. It is extremely important when you're talking about global climate change. It's produced by burning fossil fuels to generate either electricity or to power cars. It also is released when you do slash and burn farming, as we do in some areas around the equator. Forest fires, both natural and man-made, can release CO2, and curing cement can also reduce or increase CO2. This is a measurement of the amount of carbon dioxide in the atmosphere in a place in Hawaii that's been doing it since the 1960s. As again, you can see the amount of CO2 is just rising. Sorry. So this leads to, as a result, increased CO2 also leads to acid in the oceans, or ocean acidification. It creates carbonic acid, where you take CO2 and mixes with the water and makes H2CO3. And this reduces the pH of the water. What this does, is it bleaches coral reefs. And we have great images of this destruction. Sorry. It also dissolves shells of crustaceans because they're made of calcium carbonate, which is very susceptible to lower pHs. The next greenhouse gas we should talk about is nitrous oxide, N2O. And nitrous oxide is produced by natural bacterial processes in the atmosphere and in the soil. It's also made in the process of fertilizing soil and livestock manure. And it's also made from leaching of fertilizers into water as well. Methane is the third greenhouse gas, CH4. It is produced from processing of natural gas, so methane. Livestock, particularly cows, burp and they release methane. And also rice production produces methane. The bacteria that are in the water release methane. The next one we have is chlorofluorocarbons. You might be saying to yourself, well, I've heard of that before. You have. In ozone depletion, when we talked about the ozone hole that were causing that. Well, CFCs are also greenhouse gases too. They're produced from refrigerants, aerosols, cleaning products, as we said in the previous unit. And they have a global warming potential that's really high compared to the other ones. Thankfully, we don't have much of it in the atmosphere compared to the other ones. The last one is water. You might think to yourself, well, I didn't know that was a greenhouse gas. It is actually. The thing that we don't worry about is that it's a natural process. So if we have more water that's in the atmosphere, eventually it'll come out and it will be precipitated. So the average doesn't really change. So what are some of the effects? Some of the effects are that you are increasing the average surface temperature of the Earth. Precipitation is going to increase. You have heat waves and droughts increasing. Glaciers and ice caps and ice sheets that are above the surface of the water will melt and release water into the oceans that will increase the sea level. Also, with the increased temperature, you're going to expand water, and that will also increase the sea level. There are lots of other effects. As we said, rising temperature. 1.1 degrees Celsius in the last 100 years, 1 to 4 degrees in the next 100 years if the trends occur. This is again another image of the increase of CO2 and of the temperature together. These are some of the places that have changed a lot. A lot of places have increased in temperature in terms of the Fahrenheit temperature. Only a few places have actually stayed the same or decreased. Rising temperatures will cause many different things, as we said. Forest fires, droughts, increased photochemical smog. Remember that more sunlight, more heat causes that smog. Glaciers will melt, seawater will expand, and increase evaporation of water, which will cause more precipitation and more severe weather patterns like hurricanes. Interestingly, it will also change the seasonal timing of planting plants blooming and pollinators, and breeding and migration. And if you increase the temperature, it's going to expand the range of where pests and invasive species and disease vectors like mosquitoes can live. So you'll see the spread of disease happen in places that weren't normally showing that disease. As we said, glaciers will melt. This will expose more land. And what this does is it decreases the surface albedo. Albedo is a word that describes the ability of a surface to reflect light. So if that decreases, that means we're actually going to absorb light, not reflect it. And the more we absorb, the more sunlight will be hitting the surface and absorbed, so the temperature will increase. So this is a positive feedback loop. This is an example of those glaciers melting. And it's causing the sea levels to rise. These are places around the country, mostly on the coast, where a sea level rise will increase the risk of flooding in that area. And this affects so many different things. Loss of coastal wetlands and forests, increased floods of sewage treatment facilities because they're often near water sources. Coastal reefs will be degraded because they're not normally under that much water. Decreased aquatic biodiversity for sensitive ecosystems. Increased costs of coastal properties because the insurance will be much higher. Property damage as a result of more storms. Displacement of coastal inhabitants. We're already starting to see that, people moving away from the coasts. And that's it for our first video.